In problem number 4, we are asked to find a point where the function f of x equals 2x plus 18 over x has a relative maximum. So just like in previous problems, in this problem we will begin by calculating the derivative of this function. We will set the derivative equal to 0 and we will solve for x to find the critical points, because the reason we're doing this is because relative maximums or relative minimums, they always occur at critical points. Okay, so first step is to calculate the derivative of this function. The first term 2x presents no difficulties. The derivative of 2x is 2. It's the slope of the line y equals 2x, or the rate of change of 2x. You may have a little bit more difficulties differentiating the second term. You could use the quotient rule, but it is actually easier to calculate the derivative if you rewrite 18 over x as 18 times x to the negative first power. Then you could find the derivative using the power rule. And so it will be 2 plus 18 times negative 1. Just to remind you that the power rule is the following rule. It says that the derivative of a power of x, let's say x to the power n, equals n times x to the power n minus 1. Okay. This is the power rule. And so if we use it with n equals to negative 1 for the power x to the power negative 1, this is going to give us negative 1 times x to the negative second power. Now let's remember that x to the negative second power is the same as 1 over x squared. And because we also have a negative 1 in front of it, the derivative simplifies to 2 minus 18 over x squared. Okay. Now let's set it equal to 0, and we will solve for x. Let's move the negative 18 over x squared to the other side. 2 equals 18 over x squared. Let's multiply both sides by x squared. 2x squared equals 18. Let's divide both sides by 2. That will give us x squared equals to 9. And then let's take the square root of x, and let's also keep in mind that when we're solving x squared equals to 9, the x value could be equal to positive square root of 9 or negative square root of 9. Namely, we're going to get two solutions. X equals to square root of 9, which is 3, or x equals to negative square root of 9, which is negative 3. Now, next, so we have two critical points, positive 3 and negative 3. And to determine which of these points is a relative maximum or which is a relative minimum, or perhaps maybe some of these critical points are neither maximum nor minimum, we need to look at the signs of the derivative. And let's go ahead and mark on the number line. The two critical points that we found. And in addition to these two critical points, we would also want to add another extra point, which is kind of like a critical point, namely the point at which the derivative is undefined. So if you look at the if you look at the formula for the derivative that we found, 2 minus 18 over x squared, this formula can be used to calculate the value of the derivative for all values of x except for x equals 0. That is because if x is 0, then we would have to divide by 0, and we can't. In other words, for x equals to 0, the derivative is undefined, and those points are also considered to be critical points, especially if the function is defined at that point. So let's add this extra point into our picture, 0. And so now we have the number line with the critical points marked, -3, 0, and +3. And our next goal is to determine the signs of our first derivative on these intervals. By signs, I mean we need to know whether the derivative takes positive values or negative values on each of these intervals. Now, we could use test points to determine that. So you can take, let me keep the critical points in blue and change the color for the test points. So I'm going to mark the test points in red. So for example, I can take a test point as a -4 for the test point on the first segment. I can use maybe -1 between -3 and 0. I could use 1 between 0 and 3, and I can use, for example, 4 between 3 and positive infinity. What we want to do with these test values is we want to plug them into our derivative and see if the derivative is positive or negative. So let's go ahead and do that. Actually, let me scroll down a little bit so we can see the formula for the derivative. 2 minus 18 over x squared, that is our derivative. And so, for example, at -4, the derivative at -4 equals 2 minus 18 over -4 squared. And we don't really care about the exact value of this derivative. We just need to know whether the result is positive or negative. And in this case, it's clearly positive value. By the way, notice that if we change -4 to a +4, the value will not change. So the derivative at the value of the derivative at x equals to +4 would be exact same, and so it will also be positive. And I will mark these results on the sign diagram. I will put pluses for the first segment. Right here, f prime of x, to indicate that these pluses or minuses that we will have in a second in this diagram refer to the signs of the first derivative of this function. And now if we plug in positive or -1 instead of x into our derivative, 2 minus 18 over x squared, so either positive or -1 squared, this is going to be negative. You see, it's actually going to be -16. And so we see that the derivative is negative both on the second and third intervals. Now, what does this tell us? It tells us that the function is increasing on the first segment from -infinity to -3. The graph is going up. And then after it reaches the point x equals to -3, the function begins to decrease. It continues to decrease from 0 to 3. And then at x equals to 3, the graph reaches its bottom. And then starts going up because the first derivative turns positive. So what we see here is that x equals to 3 is going to be a relative maximum or local maximum, whereas the point positive 3 will be a local minimum. Okay. So here we will have a local minimum. Now the problem was asking to find the point where the function has local or relative maximum, and we see from our analysis that that point is -3. So the answer for this problem is x equals to -3.